you'll have the extra bit of the review here to help you out. Oops. Okay. So if we go back to what we were talking about the other day, or yesterday, about the restrictions when you're graphing these types of polynomials, rational functions, if you will. We had that nice little cheat sheet. Algebra 2, you probably maybe remember that. Now, when we go to graph this, there's a couple of things you have to worry about to start with. When I graph this first one, I know that I have x-intercepts at the 0 of the numerator, correct? That was the first part. So the 0 of the numerator here is 3. So I have an x-intercept at 3. I have the second step there was a vertical asymptote is going to occur at the 0 of the denominator. The 0 of the denominator is -2. The third part is that horizontal asymptote. That's when you worry about the degrees at the top and the bottom. Okay. So the top and the bottom here are the same degree. So if they're the same degree, all you're doing is looking at the coefficients in front of the values, or excuse me, in front of the variables. So in this case here, my coefficients are both 1 and 1. Therefore, what's 1 divided by 1? So I have a horizontal asymptote at 1. You're going to say something?
Are there going to be any graphic problems like this on
Probably.
like, okay, well, yeah, but like
I think when we get to something like this as far as graphing, I know the idea that you should be able to, obviously you'll have note cards, so you can write down where your asymptotes and stuff like that, things like that would occur. I think that I would give you guys a dumb calculator for the work. You know what I mean? If you had to substitute in values.
Oh, yeah.
Does that seem fair?
Yeah.
They were like, how would you like to?
What I'm saying here is that we can still at least pick a couple of numbers and get an idea of where the curve is going. All right? And go from that. Yes, ma'am? The x-intercept of 3. You remember that list I gave you yesterday? The very first thing in there, it said x-intercepts are located at the zeros of the numerator. Yep. Yep. Remember when you did factoring, we went up all those terms? When you said what's the 0 of the term, we just said it's the opposite of what the key value is. So here it's x minus 3 would be, that's all it is. Okay. From here, yeah, Jenna?
Wait, where'd you get the asymptote at 1?
Remember the third step on that sheet said that your asymptote's going to be located, your horizontal asymptote will be located, since your degrees are the same, you look at the coefficients at the top and the bottom.
And so then it's just like 3.
What's that?
Oh wait, so then is it just the degrees or whatever?
Yeah, see how this has the first degree, this is the first degree? When we did this last year, we graphed a lot of them that had like an x squared up top and then an x on the bottom, and then we had different types of asymptotes. These so far are just been first degree rational expressions. Okay, that's all. So that's how I got that one. If I'm not mistaken, doesn't this one go second quadrant, fourth quadrant?
Yeah.
Okay. Just for time's sake, I know you guys probably could have used a calculator and gone through and done something like that. The difficult part of this problem is to find its inverse because you have two separate x values. This was that tricky one that you had to set up and then you had to factor something out in the long run. So what I'm going to do is for my inverse part is that I'm going to say that x is going to equal y minus 3, y plus 2.
How did you just figure that out?
I didn't. I haven't done that.
Oh, it's the same thing.
Oh.
I was gonna say, how did you just know what it was off the top of your head?
Man.
Alright, let's keep going.
Okay. I got fraction equal fraction. I'm going to cross multiply. So I'm going to get x times y plus 2 is y plus 3. Distribute my values of x.
It's y minus 3.
Oh, thank you. Sorry. So I have xy plus 2x is y minus 3. Now, I'm going to move the y over so you have both y's on the same side, and then just take that 2x to the other side. In doing that, we wind up with xy minus y equals negative 2x minus 3. Are we okay with that? Now I can group out or factor out a value of on the right hand side. I can factor out a y now. The GCF here is y, so by taking that out, I'm left with x minus 1, which is going to allow me to get y by itself by dividing by that term. So y winds up equaling negative 2x minus 3, x minus 1. Okay? And then you go through the whole process again of figuring out asymptotes and all that kind of fun stuff. There's a second graph.
Oh, okay. That makes a lot more sense.
Miss Wallace. Didn't want to help you. So we go through it again. We have zeros of the numerator. 0 of the numerator is going to be negative 3 over 2. Add 3 divided by negative 2. We get negative 3/2, so that's negative 1.5 for a horizontal asymptote. I'm sorry, vertical asymptote. Oh, wait. What's it called? One of them, the 0. So at negative 1.5. I have the vertical asymptote for this one where? 1. It is a bit. And then horizontal asymptote. These guys, again, have the exact same degree. First degree is 2x, first degree is x. So it winds up just being the coefficients divided together. So it's going to be negative 2 over 1, which is negative 2. What's that? I put the horizontal asymptote. The third one here, this is a whole lot of mumbo jumbo for the graph of f at most has 1 horizontal asymptote. If m is less than n,
I already reading.
anyway, so that's how that works. It's a matter of just writing those things through. This one, I think, boundary out. Did they stay in the same spots, I think, or no, did they switch? Hmm? I forgot which way they spurred. Yeah, they're the same spots. So this one's just going here,
Can you do number 52?
and this one's going like that. Okay. We didn't talk about domain and range real fast. What is the domain and the range of the first function, of the original function? The domain, well, domain is going to be, where's,
Is the domain like the top and then the range is the bottom?
not necessarily. Remember, domain is your restriction. Is there a restriction anywhere on x? And the first one, yes, your domain for the first one is all x not equal to negative 2. Okay. The range, I think you had a vertical asymptote, or I'm sorry, a horizontal asymptote, didn't we? At 1? Is that the first one? Yeah. No, the blue. I'm thinking blue one. The blue one had a vertical asymptote at negative 2. So the range is when it's not going to equal. Well, actually, the range here is not going to be a problem. Wait. Oh yeah, at 1, the asymptote here.
So
Where's
the
that?
range?
Range is y not equal to 1. Where's the horizontal asymptote? So your range is going to be restricted by the horizontal asymptote. The domain will be restricted by the vertical asymptote. Okay?
Wait, range?
I'll write that down. This is a good thing to remember. domain restricted by vertical asymptotes I can't spell asymptote. ASMY, we'll call it that.
What?
I don't know.
That's ASYM. PETOT.
Degree in math, not spelling. SMRT.
TRUTH.
Range restricted by the horizontal asymptote. Because you can't get to it. It's going to stop to it when you approach it. Okay. What's the other one you want to look at? Your head's going to explode, isn't it?
Yeah.
You're okay, Devin. You'll be fine. You'll be all right. 52? Okay. Hey, it's a good thing we're not taking a test on Friday, right?
Yeah.
Yeah.
It wouldn't be that bad. As long as it's not consistent.
Shut your mouth.
It's just a small amount of hostility, right? Okay. So first thing we got to worry about here is we have a function of x to the 3/5. Well, that's no fun. That means it is the 5th root of x cubed. Boy, good luck finding numbers that work for that.
Yeah, that's.
Have you ever given I will.
So this, you kind of have to have a calculator to do this one, don't you think?
Yeah. No, we don't.
Kinda.
You
We
need one.
have to.
So let's do this. Let's just figure this out as far as the inverses by hand. Because doing the inverse of this is very, very easy.
It's a 5/3.
All right, so we have, if I flip-flop to get my inverse, we'll do that first, then we'll go back and talk about domain and ranges and stuff. We wind up with x equals y to the 3/5. How do you undo a 3/5? How are you?
5/3.
You 5/3 it. Reciprocal.
I know, but I don't remember doing this.
Power to power.
You could just go to sleep last year.
No es bueno. Lo siento, es muy cansado en su de clase de matemáticas.
That was actually
I didn't see it.
Spanish degree too?
I never just signed up.
Es un puerto.
Sorry.
La ventana está ahí.
Last but
Lo siento. Es un reloj.
Great.
Tengo dos zapatos.
Bye.
Adios.
Bro, I just Spanish last year.
Did you say bro?
Yeah, you know more than I just took 3 years of Spanish.
Cuatro años español en una escuela.
That's what
23 años.
23
Ago.
years ago.
You wouldn't say what it was.
Yeah, basic
And you gotta love the white Chicago accent with my Espanol. Hola, ¿cómo está usted? It's awful.
You sound like
No,
Yes,
but-
I've heard that. Anyway, so our inverse is pretty easy to find. Just flip that over and go. Now, when you go to graph these,
And he like stands like this, and he's like, these are stands.
Okay, so we're
those are great movies. When you go to graph these things, these values are awful. Okay.
Yeah.
Yeah, we like.
Wait, what happened when you did
I just put my practice.
No, I know, like you said, you must not get into that. Like you had like a
Oh no, I was saying I was putting that in that value to try and figure out what numbers can I substitute in to get values out. Like cubing something to get into a perfect 5th root. Yeah, good luck with that. This is what I'm saying. Something like this, you're gonna have to have a calculator to calculate zeros.
I ended up getting that like
I do know for certain that it's gonna go through the origin. I got that going for me. Yeah. Well, you do. I'm gonna use a calculator.
What was the domain?
Alright, so.
Yeah, there's no asymptote
So we
here.
have one without a calculator, it'd be like the last.
Yeah.
But there is asymptotes.
Now, yeah, you'd be able to write it out, but these aren't going to have all real problems.
For Walmart.
Even for all of these, we just did.
No, just for this one, you're going to be all real. So I'm going to go ahead and graph this. So you might want to use your calculator so you can kind of see how you can find a table and all that. It's not that bad. What was it? X to the, I can't see anything without the lights.
Turn them off.
Ooh.
Now you guys probably can't see anything. Sorry about that.
Yeah, we can.
If I hit control, is it control book? I can't see it from here. Nope. Control.
To get like the menu pop up above it.
Yeah.
You don't have to hit control, you just hit the one above the button.
Was
The
it
one
this
to the
one?
left of the button.
Oh, okay. I couldn't see which one it was.
Well, you can go.
Okay, there it is.
That's for your graph.
Okay. Gotta back out. All right. So this one here, I'm gonna go X to the should be. Oh, I hit the wrong button. I'm thinking the old calculator is not that one.
Wait, wouldn't it be the x to the 3/5?
Now I'm going to do that again to create a fraction. X to
You did that
the.
the really hard way.
I'm sure there's an easier way. I'm still learning on this calculator, so we get that. Good.
Okay. Yesterday we
Okay.
had project and it really hurt, so I don't want to.
So there's my first graph. I do that again by hitting. Oop, sorry, I hit the wrong button. Hit tab. Hit tab to create a second function. And this one we're going to graph it was 5/3, I believe. So it should be x to the.
Wait, why did you?
And you get to mirror itself through. Obviously, you have to have a calculator to make this one work to get some sort of numbers that'll be able to plot. What I can ask you on this is, what is the domain of the original function? All real. What is the range of the original function? All real. What is the domain of the inverse of the function? All real. And what is the domain, or what is the range of the original function? Or the inverse, excuse me. All real again. So the reason I know that is because there's no asymptotes. There are no asymptotes thrown in here. It is continuous going from left to right. That's all it is. Quentin, what do you got? You're Jen, all right? Yeah, Jen.
Does it show where the asymptotes are, or like?
What'll happen is if you go back to the other one, remember the easiest thing to remember when you have an asymptote is if it's a variable in a denominator. Okay? That's usually the dead giveaway you're going to have asked because it's a 0 in a denominator. When you don't have a variable with a denominator, or a variable in a denominator, you're not going to have that. Okay? And since it's not an exponential function, we don't have to worry about the horizontal asymptotes. We haven't gotten there yet. All right? You're okay. Yeah, you're fine. You just don't have the other graph in there yet. That's all.
Oh, well, I don't know how to really work yet, so
You're getting there.
I don't even know how to do it yet.
What I found is if I just make home and start over,
Yeah,
just redo it.
because I think I kept like 14 graphs.
That's the way. I know there's.
I did.
Or you have to do it on your graph.
Let's talk a little bit about this one-to-one. Hold this one because we'll continue. We'll add to a couple problems from tonight. I really only have a couple of definitions to talk about
I started
today.
learning and I didn't know how to do it.
So let's finish out the last little bit of
Yeah, but with that one.
1.9. Bless you.
Yeah, we'll see into it. See why.
Look at that fancy pants. Wow. Let's talk about let's talk about our function being what's called one-to-one. When I'm talking about this thing being one-to-one, this is how you're going to be able to tell whether or not something is going to have an inverse. For example, a second ago I said that y equals x squared. Since there's no, if we don't put a domain restriction on it, it is technically does not have an inverse because it's not one-to-one. So what that means here is real, very basic definition. Instead of going through the book one, for every y, it's backwards of being a function. Remember how we defined if something was a function? If and only if for every x there exists exactly one y? Well, to be one-to-one, it's for every y value there exists only one x. So if you think about it in terms of, if you look at a table, if I have x and y, and I'm looking at y equals x squared. If I do that, -2, -1, 0, 1, and 2, we get 4, 1, 0, 1, and 4. For every value in my x column here, there exists a y. For if I flip them, sorry if I want to make sure I flip them the right way so I don't mess you up here. There's going to be a real nice, easy test to do this. And this is how it works. Oh, yeah. If we take the values of, if we flip the y column and make them x's, if I take this column and make them x's, remember how A to B, B to A? If I flip those through, you'll find out that you get a repeater. Yeah, it's so well, it's nice. What happens here is, see how the 4s repeat? If you look at this in the graph, we all know that the y equals x squared, or y equals x squared, it's just a generic parabola. We all know that, right? It is a function because it passes the vertical line test. Remember the vertical line test, if it only touches it in one spot? It's one-to-one if it passes horizontal line test. Since these values touch it in more than one spot, y hits in 2 spaces, that means that function is not one-to-one. That's what that means.
Wait, so it has to pass both?
No, just this. To be one-to-one, it has to pass, it needs to pass the horizontal line test. So basically, if you want to think of it as, is that repeating itself somewhere? If you look at a curve, you look at an even power, usually. Parabolas. Parabolas, if they're not restricted to a single half of the curve, won't pass the horizontal line test because there's 2 parts to it. But yet, parabolas are functions because they pass that. Okay? You guys did this last year. Remember when you did, was it x squared equals 4py?
Yeah.
or y squared equaled 4px. Those were conic forms of parabolas. One of them was up or it was down. The other one was opening this way or this way. These were functions because they passed a vertical line test. These were not functions because they didn't pass a horizontal line test. Last year, remember last year when you guys graphed conics, when you turned them left and right? We knew that they were not functions because they didn't pass the vertical line test. But yet these would be considered one-to-one because they passed the horizontal line test, but not a function. So these would technically have an inverse, whereas this, since it doesn't pass it, doesn't have an inverse. That's what I'm saying. The reason that we were able to do that problem a little while ago, when they said y equals x squared and they restricted it here, is because we were looking at that half of the curve, which therefore passes that horizontal line test. That way you can do it, okay? That's why we were able to say it had an inverse and it went this way and they were symmetrical through that. That's why we can do that. And we didn't talk about that yesterday, and it's really not that difficult of a thing to see because all you have to do is look at the curve in your calculator and see if it goes through the line. It hits it. That's really all it is. To be one-to-one, you're one-to-one if you pass that horizontal line test. So if the curve doesn't get touched twice by a horizontal line, it's one-to-one. That's all it is. Okay? Yes. The only other thing that's in here that I had you guys looking at for tonight. Yeah, where you have f of x, and why don't you see if you can figure this out? Correct. You do it the same way. This is a composite of functions again, but in this case, it's doing a composite of their inverses.
So we got to find the inverse of the
Basically, yes. Okay?
Oh, so it's like the inverse
Yeah.
of
Yeah. A little bit more, but in essence, you're on the right track. So you're on the right track. So if I'm looking at this problem, first thing I'm going to do is find the inverse of both f, and then find the inverse of g. By now, I'm hoping that finding inverse is pretty quick and painless. I hope.
Yeah, that's good.
So we have x equals, let me change the colors and see. X equals 1/8 y minus 3. So this becomes 8 times the quantity x plus 3 is y. Add 3, multiply by 8. Okay, I won't skip steps. So, add 3.
Multiply by 8. Oh, I thought you meant from there.
And then it was 1/8, so I multiplied by 8. So f prime, the inverse of f, you don't have to. If you want to write it as 8x plus 24, that's fine. Not a big deal. You get that for its inverse. Do the same basic thing with g of x. G of x should be pretty simple again. X equals y cubed, therefore it's the cube root of x is y.
But then you have to put that where the x is.
The composite, remember what this means? It's f of g of x.
Well, did you substitute the 2 for x?
Yep. But they're saying using of 2, so that means we have to take the 2 in here, figure that out, and then send it into here.
Oh,
Okay.
so you put the 2 in the g.
Yeah, you know what, let's do this. Let's make this an 8 so it works, instead of having a crummy number. So we'll use this as,
Or you could do 1.
we can do 1. But I could, but I don't want
Maybe
to.
1.
No!
Oh.
You can leave that one for you. Hi, how are you?
Great, how about you?
I'm doing fantastic, it's good to see you. Hey, thanks.
No problem.
See you later. I don't know.
It was
Sorry. Okay? And then just go from there. It just looks, it's still a composite, but instead of just using the original functions, you're using the inverses. That's all. Okay? The last two questions that are in the homework then tonight are looking at the table, and use the idea of flipping the tables to see if it would pass that horizontal line test to see if you're going to be able to make a function out of it, or inverse from it. It should not be as complicated as what you guys would think. Okay?
Okay, wait, question.
I try. Yes, ma'am.
Okay, so like the cube root 8 plus 2. So then I put 8
Times 2.
2 times 2 plus 24.
That's 8 times 2 plus 1.
Yeah.
Yeah, you said it twice. That's just make sure.
Oh, I didn't mean to.
Yeah.
Do something
That's all it really is. Okay? And we'll go from there.
So 16 plus 24.
We should have enough time then tomorrow